Hello everyone, I'm Trishul. I'm a front-end developer and a JavaScript enthusiast. By day, I architect some e-commerce solution for Westwing, and by night, I'm a Mozilla enthusiast. So, today I'll be talking about destructuring front-end monolith with microfrontends. So, what is a monolith? By definition, monolithic application is designed to be a self-contained. Components of programs are interconnected and interdependent. So monolithic applications are self-contained applications, the component of which are tightly coupled to each other, interdependent and interconnected. Components like UI elements, database, everything goes together. In modern day, this monolith has already been broken into backend and the frontend, and eventually backend has been broken into microservices. This worked fine for a long, but with evolution of JavaScript, we have lots of code now in frontend. Frontend hosts major chunks of business logic. With lots of code comes lots of complexities. And now what we have is again called a front-end monolith. And with this, we have all the problems of monolith again. All the code is in a single place. Increasing size of repo every day. Every feature we add increases the size of the code, and eventually it increases the complexity of the code. Since lots of teams are working together on the same code, we have increased inter-team dependencies. And as a result of all of this, our development to deploy cycle has been slowed down. Moreover, the whole team is as strong as the weakest link. If any team has broken anything on the production, all the teams are blocked. No one can deploy anything else until this thing is fixed by the team. So, what is our solution? Enters Microfrontends. What is a microfrontend? By definition, microfrontend architecture is a design pattern where a monolithic frontend app is destructured into small independent apps. These micro apps are stitched together as a single page on the fly. Consider a huge monolithic system. It has been broken into small, let's say, components, and each component behaves on its own. So, each microfrontend is a standalone system capable of running on its own. Each microfrontend has an independent repository, a separate piece of code, so that the complexity of its code is contained into this individual repository. It has independent CI pipelines. So you can have your own testing suites, you can have your own deployment pipelines, you can have your own regression pipelines whatsoever. This do not bother other teams. And finally, which I love the most, they have independent deployments. Each microfrontend is deployed individually. One team do not have to wait for the other team or is not blocked by the other team. If your code is ready, it's tested, you can already deploy and make sure your live site has the live code. As a whole, this whole microfrontend architecture enables parallel development cycle so that every team has their own domain and they can move with their own velocity. Let's have a look at the architecture. So consider this case. There are several microfrontends, remote 1, remote 2, remote 3, and a host. So these microfrontends expose their packages in the wild, and host consumes those packages. Host does not have to worry about like how these were built, how these were compiled, or how these were made available. All it needs a remote address where it can get these remotes from. Now let's have a look how we architected our e-commerce website at Westwing. So at Westwing, we have this very simplistic structure. There's a header, there's a footer, and there are several pages, let's say home page, product listing page, product detail page, payments page, and cart page, and many more. So in a monolithic world, all these code were in the same code base. All the teams were working on the same code, and obviously there will be lots of friction, a lot of to and fro, and most importantly, there were lots of blockage. Because of one team, the other teams have to wait for the deploy, we have to sync our deploy. But with microfrontends, we made every page into a microfrontend, individual from each other and independent. And these microfrontends were consumed by the host. The host has the header and the footer. We generally call it as an app shell. So when a request is made to a page, let's say for the home page, the app shell takes the request and renders the header and the footer with homepage microfrontend. So what should app shell have apart from header and footer? So what we put in app shell is more of shared business logic, which will be kind of consistent throughout all the microfrontends. So one of such logic is login logic. So all the login mechanism we put in app shell. If user needs to log in, so instead of microfrontend initiating the login process, it sends a signal to app shell, and app shell initiates the login process. If the user is logged in, app shell returns the data of the logged in user, else it shows the login pop-up or whatsoever is the logic. But this is consistent in the app shell, and Microfrontends do not have to worry about it. They just send the signal and get the response. The next thing which we put here was tracking. So our e-commerce site have different third-party tracking, so which is common throughout the system. So instead of putting it in each microfrontend, we put it in app shell so that it's uniformly available throughout microfrontend ecosystem. So if any microfrontend needs to send a signal, they send a signal to app shell, and app shell eventually sends it to the third party. This makes sure that we maintain the consistency of tracking, and we have a single place where we can monitor what tracking is being done. If we want to log it, if we want to debug it, so it comes really handy. Next thing we put there was system config. So we use lots of config like the environment config, the pipeline config, and whatnot. So instead of putting it in all the microfrontend, we just put it in app shell. And then when any microfrontend needs some of it, they just request from app shell. So app shell basically holds the single source of truth for all the configs throughout the system. Whosoever microfrontend want some configs, they just request it from app shell and get all of it. And then the final thing which we put in app shell is the routing. So app shell is responsible for building all the pages because it has the header and the footer. So we put all the routing logic within the app shell. So for example, if you make a request for a listing page, so microfrontend listing microfrontend is invoked by the app shell, and it is rendered with the header and footer, and finally the complete page is served to the user. So these are some shared business logic which we put in app shell, called maybe you can call it host. So we have been talking about like lots of data transfer between microfrontend and app shell. So we need to understand how the communication between microfrontend and app shell has been set up. So there are generally two ways. So in microfrontend ecosystem, if we are using the same tech stack, let's say microfrontends are in React and app shell is also in React. So the communication is a very easy process. We can just share the props, like any React component except the props, and it behaves. Props can be a data or props can be a function. So if you want to change the property of the parent, you can pass some function, and eventually the child component will change some property in the parent. Simple React flow. So this shared component is still a React component. So it will still behave how the React behaves. So there is nothing extra layer which we need to do. And the other way is if we have, let's say, Vue.js or React or Angular, let's say, basically some different tech stack, not the same tech stack throughout ecosystem. Then we use something called as custom DOM events. So what are custom DOM events? So custom DOM events are just user generated events. This behave exactly like any other events of the JavaScript, but it's just we can create our own. In our Westwing system, we also use custom events for communicating between one microfrontend to another. Sometimes it's easier rather than just passing down lots of props. So yeah, let's have a look at some custom DOM events. So it's super easy. All you have to do is, let's say I have defined an event called as my event. You subscribe to this event like any other event, like adding listener, maybe to the document, to the element, whatsoever you feel comfortable with. And how to trigger this event, how to fire this event. So you have to create a new custom event with your name, and you can pass the data whatever is required for you. For example, I pass is clicked. And when this custom event is ready, all you need to do is dispatch this event. So this dispatch event will make it available for all the subscriber in the window. So it has nothing to do with microfrontend, app shell, or anything. It is plain native JavaScript. So everything which ends in the browser is JavaScript, HTML, CSS. So it doesn't matter whichever microfrontend you are, whichever app shell you are. If an event is fired and it has a subscriber, the subscriber will get the event. So based on that logic, we built this whole messaging system using custom DOM events, and that works pretty good out of the box solution for communication. Now we have seen the architecture of the microfrontends. Now let's see how we implemented this one. So there were several ways we tried to implement the microfrontend architecture. Initially, what we did is like we have small components and then we exported them as node modules and imported them into the projects. This way worked for a while, but still it blocked our deployment because eventually at end of the day, you have to deploy these node modules with the incremental version into the main app. So we are still at the same problem. But with Webpack 5, we have module federation. So module federation allows Webpack to reference some modules which are not present at the compile time, and they can be available at the runtime. So let's have a look at this again. So when we compile host, we do not need to have remote 1, remote 2, remote 3. We just pass the reference of remote 1, remote 2, remote 3 with help of module federation plugin and assume that they will be there when the application will be up and running. So this allows to compile the host without any external remotes. And remote 1, remote 2, remote 3 are compiled separately and ready for consumption. So on the runtime, when the app is up, it looks for the remote 1, and when it gets the packages, it just chucks into the host compiled code and behaves like any other component. Now let's have a look at some code. So consider this main.jsx. It's a simple React app. It is just a component rendering h3 with a title as a prop. So we need to expose this component into the wild. So how would we do that? So it's pretty simple. This is our remote config. This is basically webpack config. And in this webpack config, the first thing we need to do is include module federation plugin. So this is native webpack plugin, which comes with Webpack 5. So it has first entry as remote 1, the name. So this is the namespace with which it will be known into the host. The second one is the file name remote entry. So remote entry is a file which is created with the module federation. So consider this file as a metadata file. It contains all the address, it contains all the address and the package and the relation between these packages when which package has to be loaded. And then we have this exposes. So this is the place where we define which component we have to expose. For us, it's src/main.jsx, and with which namespace it will be exposed. So it's main. And the final thing which we have is shared. So what module federation allows is, like if you are in the same ecosystem, let's say everywhere you are using React. So you should not load 2 copies of React into your app. So this shared key allows you to define what all libraries you expect to be provided from the host. So in our case, we say React and React DOM, please use it from host and do not load a copy of it from Microfrontend. So with this, the module is already exported. So now this exposed module has to be consumed, and let's see how we will do that. So again, this is the host config of Webpack. So again, here we have to here we have to include module federation plugin and give a namespace, host namespace, and then we have to define the remotes. So we need to define like what all remotes will be available. So let's say we define the remote 1 and its address where it can pick up the remote entry.js, the entry file, which will kind of explain the rest of the things. And then finally, again, the shared. So as I explained before, we can define some modules, which can be not modules, libraries, basically vendor modules, which can be shared from host to all the microfrontends. So with this, the connection has already been made between the microfrontend and the host. So this host will consume the microfrontend remote 1, which will be available at localhost 3002 and having remote entry on that address. Now the connection has been made, but still we haven't used the component. So let's check how to use that main component. So it's as simple as this. It's literally like this. If you look at the second line, import remote app from remote1/main. So remote 1 is the namespace of the exposed remote, and main is the namespace of the exposed component. And then remote app can be used as any other React component throughout your app. So you can pass the props to it, you can render it, you can conditional render it, whatsoever you want to do with it. And with the simple steps, you're already having a Microfrontend setup running. So I have prepared a small demo and let's have a look at it. So here I have two projects, host and remote. In remote, it's a simple React setup with a webpack config. In the webpack config, we have module federation plugin with namespace of remote1, remote entry, and it exposes a shared component which is present in its source folder. And in addition, it expects some shared libraries like React and React DOM from the host. Let's have a look at the shared component. The shared component is just a h4 rendering current count, which is counter the value passed from the props. Let's have a look at the remote app. It's a simple app, remote app. It has a shared component, and the count value here is just one, static one. Now let's have a look at the host. In the host, in the webpack config, again we have module federation plugin. It's a host namespace and it accepts a remote1 at the address localhost 3002. And it exposes some shared libraries like React and React DOM. And now let's have a look at host app. So host app basically imports React component, remote component from remote1 namespace and shared component namespace which was exposed. And this, it simply uses it as a component and pass a counter to it. This counter is a state variable, and on a button click, it increases the counter by 1. So this is basically a functional component and it's passing state to the remote component. So let's see how this works in in browser. So let's make it run. Let's run the remote first, and then let's run the host. So this is on localhost 3002 and this is on localhost 3001. Let's have a look at both. Let's have a look at the remote first. In remote, if you can see, it's a simple remote app with current count 1. So the inner box is the shared component which is available in the remote app. Now let's check our host app at 3001. Here again we have the same component, shared component, but it is being served from the remote. Let's quickly have a look at the network and just reload it. And if we see, we have a remote entry, main.js, which is initiated by main.js. And then remote entry in turn invokes lots of modules here. Like for example, shared component, which we need. And let's check the functionality of this. We increase the counter 1 by 1. So the upper one, the count in host is 5 and current count in shared component is 5. So basically it's seamlessly forwarding the state from host app to the shared component. This is the magic of module federation. It really seems out of the box, just same native React component as if it was present in the scope of this host project. So with this, we have lots of power to module federation to make sure our React components still work the same way, even if it is not included in the project. So let's get back to our slides. Okay, so we have implemented Microfrontend in Westwing in our shop, but it was not piece of cake. We have a bit of challenges while developing this Microfrontend. So I want to share some of our challenges with you. So first one was design consistency. When we were splitting out Microfrontends, one of the major concern of us was like how to keep the design consistent throughout the Microfrontend. Right now we have a conscious like, okay, we will do this, but when the team grows, when the code grows, how will we make sure that the design is consistent throughout all the Microfrontends? So what we came up with was a design system. We have something we call as UI kit. UI kit is basically house of all the components which are available for the UI. For example, button, search bar, drop downs, checkbox, etc. So whatever UI component we have, it should be in the UI kit, and then every micro frontend should use it from the UI kit instead of implementing of their own. Even if they want to implement their own, first we implement that in UI kit, and then we consume from there. And we have to make a small storybook for this one, so that everyone knows what elements are available in the UI kit. And this actually helps the new developers and also the designers to know what we have, and so that they can infer from our design system. The next challenge we had was initializing a new micro frontend. With each micro frontend, we have lots of setup. We have GitLab pipelines, we have CI setup, we have Docker setup, we have Helm charts, we have publishing to S3 scripts, and a lot of stuff on the infra side. So doing this manually is pretty kind of extensive work, and also very error prone. So instead of doing it manually for every micro frontend, what we use is a templating engine. We call it Temporato. So Temporato is very smart templating engine. It maintains different templates for us, and with the help of these templates, it spins up a new micro frontend or whatever your project is within a minute. So if we do something like this, if you can see on my screen, so this Temporato create, it uses a template project where all the templates are present, and we have several templates. But for this, we are interested in micro frontend template. So when we select micro frontend template and go ahead, we pass some variables. These variables are basically kind of namespaces, which can be kind of find and replace while creating the template. So once the template is created, out of the box we have, as you can see, Docker file, Helm charts, CI pipelines, end-to-end test, everything set up already. One more advantage of using this template engine for us is we have lots of micro frontends, and we need to make sure that all the micro frontends are in sync on the infra level. For example, if we change the let's say S3 script, how we publish it, we change some stuff there. So we need to forward it to every micro frontend. So instead of doing it that manually, we just update the template, and micro frontends update their part of the template, and it propagates uniformly throughout the micro frontends. So using a template really kind of eased our lives as a developer. Apart from these, we have some more challenges. For example, the biggest one was decoupling code from app shell. Okay, so what we did is when we decided to move to micro frontend, we said, what we have this monolith, we will call this app shell. Instead of creating a new app shell, we will have this as an app shell, and we will be taking out components one by one, so that our app shell will be leaner, and finally we will having only header and footer and some business logic in app shell, and rest everything will be a micro frontend. So to achieve that, the first thing we did was moving components to the design system. So every UI component we moved into the design system, and once we have in the design system, every reference of that was only from UI kit. There was no internal reference from one place to another in the code. May it be micro frontend, may it be app shell. Uniformly, anything which is related to UI has to be in UI kit, and it has to be referenced and used from there itself. So doing this actually kind of halved our work, because this enables us to decouple lots of stuff already, even in the app shell. Now, sharing the logic between micro frontends. Next thing which we want to tackle was some logic which is static. It does not require data, but for example, price formatters. So we want our website to have the same price formatting throughout the website. Like maybe any micro frontend, maybe any page, we want it same. So instead of copying this logic into every micro frontend, we created some small utility NPM packages, like price formatting helpers or some date formatting helpers. So these are small helpers which we use throughout our micro frontend system. So whenever we find a utility which is shared by more than 2 micro frontends, we create a small package out of it. And these packages are used. This logic is used from the packages rather than just writing it twice or thrice. So this kind of still makes sure that our code is consistent, and we are not kind of using different logic at different parts of our website, which is eventually a different micro frontend. And last but not the least, building an efficient developer experience. So once we have all this micro frontends ready, the biggest problem we had was, like, let's say we have one app shell and 3 micro frontends. To develop it locally, we have to run all 4 together. So on 3001, 2, 3, 4, we were running micro frontends and the app shell, and then we were able to make some change. And this was pretty cumbersome process because it takes lots of resources. My laptop fan was really like I'm doing a coin mining or something. But eventually we get over that. So in order to fix this, what we did is we followed a Docker-based approach. So we created a Docker image of everything which is deployed on staging. And we accepted the microfrontends URL via environment variable in this Docker image. So if there is no environment variable present, we use the staging URL, else the environment variable. So when we develop on the local system, we run, let's say on localhost 3001, the microfrontend, and pass it into the Docker image with the environment variable. So when we run the Docker image, everything is used from the staging environment, but the microfrontend from the local environment. So this helped us to have a smooth and more productive developer experience. There's still things which can be improved in this, but for now, it's way better than running 4 node processes. So yeah, this is kind of a snapshot what we did at Westwing and how we were solving the problems and how we broke our huge monolith into small micro frontends and app shell. Still, we have a long way to go, but from past 6 months, the progress we have, I can totally say this is super worth it. With that, thank you everyone. Thanks for attending my talk.